Welcome to this video on Hückel's Rule, an important concept in organic chemistry that helps us determine aromaticity in cyclic compounds. Before we dive into Hückel's Rule, let's first understand what aromaticity is. Aromaticity refers to a property of cyclic molecules that makes them unusually stable. Aromatic compounds have a ring of atoms with delocalized pi electrons, which means the electrons don't belong to any specific atom, but are shared across the entire ring. Now, how do we determine if a compound is aromatic? This is where Hückel's rule comes in. According to Hückel's rule, a planar, cyclic molecule will be aromatic if it has 4n+2 pi electrons, where n is any non-negative integer. When we calculate this formula for different values of n, we get the allowed numbers of pi electrons for aromatic compounds. Let's calculate. For n equals 0, we get 4 times 0 plus 2, which equals 2 pi electrons. For n equals 1, we get 4 times 1 plus 2, which equals 6 pi electrons. For n equals 2, we get 4 times 2 plus 2, which equals 10 pi electrons, and so on. Let's examine some common examples of aromatic compounds and verify Hückel's rule. First, let's look at benzene, which we saw earlier. Benzene has a 6-membered carbon ring with alternating double bonds, which gives it 6 pi electrons. According to Hückel's rule, with n equals 1, for n plus 2 equals 6, so benzene is indeed aromatic. Next, let's examine the cyclopentadienyl anion. This is a 5-membered ring with a negative charge, giving it 6 pi electrons. With n equals 1, for n plus 2 equals 6, confirming it's aromatic. Let's also look at an example of a compound that isn't aromatic, cyclobutadiene. This 8-membered ring has 8 pi electrons. According to Hückel's rule, aromatic compounds should have 4n+2 pi electrons. 8 equals 4 times 2, which does not fit our formula of 4n+2. Therefore, cyclobutadiene is not aromatic. In summary, for a compound to be aromatic according to Hückel's rule, it must meet several requirements. 1. The molecule must be cyclic. 2. The molecule must be planar. 3. Every atom in the ring must have a p orbital available for pi bonding. 4. The number of pi electrons must equal 4n+2, where n is a non-negative integer. Let's recap the magic numbers of pi electrons that make a compound aromatic. 2 pi electrons. N equals 0.6 pi electrons. N equals 110 pi electrons. N equals 214 pi electrons. N equals 3 most common aromatic compounds, like benzene, have 6 pi electrons. Why is aromaticity important? Aromatic compounds have special properties, including 1. Enhanced stability compared to similar non-aromatic compounds. 2. A preference for substitution reactions rather than addition reactions. 3. Ring current effects in NMR spectroscopy. 4. Distinctive UV visible absorption patterns. Understanding aromaticity through Hückel's rule helps chemists predict molecular behavior and design new compounds with specific properties. In conclusion, Hückel's rule provides a simple yet powerful method to determine if a cyclic compound is aromatic. Remember the formula: 4n+2 pi electrons, where n is a non-negative integer. Aromatic compounds have special stability and reactivity that make them important in both nature and in the lab. Many important biological molecules, medicines, and materials contain aromatic rings. Thanks for watching this video on Hückel's rule. I hope you now have a better understanding of aromaticity and how to identify aromatic compounds.